The materials we need are one large Ziploc bag, a smaller Ziploc bag, a cup of water, filling the smaller Ziploc bag with water such that it is fully filled and it exerts a large amount of pressure on the surface of the plastic bag, a thermometer, calcium chloride from household dehumidifier, a measuring cup filled with 100 cm³ of water. To make the heat pack, fill the larger Ziploc bag with 2 tablespoonfuls of calcium chloride. Then, place the smaller bag of water into the bag filled with calcium chloride and squeeze out most of the air before sealing the larger Ziploc bag. Using a measuring cup, measure 100 cm³ of water and record down the temperature, which is 30 degrees Celsius. To activate the heat pack, smash the bag to break the bag of water inside, and shake the bag such that water is mixed with calcium chloride to start the reaction. Place the heat pack into the cup of water and measure the temperature rise. The temperature rose 4 degrees from 30 degrees Celsius to 34 degrees Celsius. One key variable that we changed is the amount of calcium chloride used. Instead of using 2 tablespoonfuls of calcium chloride, we used 4 tablespoonfuls instead. Repeating the previous steps, the temperature rise we recorded was 7 degrees Celsius, with the temperature increasing from 30 to 37 degrees Celsius.
We continue on by adding 6 tablespoonfuls of calcium chloride. By doing so, we are trying to prove that the more reactant we use in the reaction, the more energy released and hence a higher temperature rise. This is because with more reactant, more energy will be released during bond forming. This is proven by the fact that the temperature rose to 42 degrees Celsius when using 6 tablespoonfuls of calcium chloride, as compared to 37 degrees Celsius when using 4 tablespoons, and 34 degrees Celsius when using 2 tablespoons. The reaction between calcium chloride and water can be broken down into 3 steps. Firstly, the ions in calcium chloride separate from each other, forming Ca2+ and Cl-. This act of bond breaking takes in energy and hence is endothermic. Secondly, the water molecules will separate from each other to make space for the ions. It takes energy to separate the water molecules from one another, thus this step is also endothermic. Next, the ions will interact with the water molecules and form hydrated ions. This act of bond making will release energy and hence is exothermic. Since the overall reaction is exothermic, we can derive that the energy released in step 3 is larger than the energy absorbed in step 1 and 2. In other words, when calcium chloride dissolves in water, the energy released by hydrating the ions is greater than the energy required to separate the ions and water molecule, thus an exothermic reaction.